Hi, ladies and gentlemen. This is Mr. Green, and this is another in a series of the lessons on Algebra 2. Let's look at where we're at right at the moment. We should be completed with Unit 1. We should be working on Lesson 2.03, Unit 2.03. Remember, due dates. After 28 days, things do expire, and you can't get back into them. So you want to make certain you get everything that you've up to this point completed so that you don't have any zeros in the grade book. Okay? So 2.03, graphing exponential functions. Now, this is really not that bad. One thing you have to keep in mind when you're graphing exponential functions is, not to blank out the screen here, is that there are some things called parent functions. A parent function is a function that when you look at it, it's the same as your graph, except it might be shifted one way or another. Okay? So, one of the parent functions that we will be looking at is f of x is equal to b raised to the x power. B raised to the x power is called a growth function. Why? Because it's constantly growing. See how it's getting bigger and bigger and bigger and bigger and bigger like that? The end behavior is the behavior of this graph at the ends. Okay? So as x increases, that means as x is going this way, the y value is increasing and it's approaching infinity out here. Okay? As x decreases and it's getting smaller and smaller and smaller, the y value is approaching 0. It never gets any bigger than 0. That's a term that we use in mathematics. And that's a term that we use in mathematics, meaning that it gets close to a number but never touches it. It's called an asymptote. Okay? If you want to have a way of remembering this, remember MC Hammer. MC Hammer was a rapper back in the long time ago, early rappers. Go look up the MC Hammer. Can't touch this. Okay? MC Hammer was a DJ and he made this record, okay? Hammer pants. You might remember those. Those were popular many, many years ago. His little video, can't touch this. Dun, 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 dun. Can't touch this. Well, that's what an asymptote is. It's a line that when drawn on the graph, this graph line that we're looking for will never touch it. So as x is getting smaller and smaller and smaller, it gets close to 0, but it never touches 0. Can't touch this. Dun, 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 dun. That's one way you will remember what an asymptote is, okay? So the domain in this situation, since x is not changing, it's going from positive infinity to negative infinity, or negative infinity to positive infinity, however you want to look at it. It's all the real numbers. The range, however, is going from positive infinity to 0. It's always going to be greater than 0 because it can't touch 0. Never gets below 0. Nice thing about this one, if we stick 0 in here for the value of x, it'll always be 1. Why? Because b to the 0th power, doesn't matter what b is, will be 1. That's an easy way of remembering that one. Okay? Okay, so when b is between 0 and 1, what we get is a decay function. Okay? The end behavior of a decay function is as x increases, y gets closer and closer to 0. Once again, asymptote. It never touches 0. As you go backwards and y is going negative and big, like that, x is going negative, the y is going up to infinity. So in this situation, you've got a b value that is between 0 and 1, and it's called a decay. Okay? And that's what you're looking at. It's something that's getting smaller and 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 smaller. Okay? So let's look at a couple of these just to see what we can do. What we're going to do here is one way to graph these is just stick values in for x and see what you wind up with. If we take the function f of x is equal to 2 to the x power, we stick a -3 in for x, we get 1/8. So over here at -3, 1, 2, 3, we're at 1/8. It's way down here. Okay? At -2, we're at 1/4. That's in there. At -1, we're at 1/2. It's growing slightly, right? At 0, we're at 1. At 1, 2 to the first power, well, that's 2. 2 to the second power, that's 4. 2 to the third power, that's 8. And I think you can see what the graph is looking like. So one way of doing these is just stick values in for x, come up with a table of values, and show what it's going to look like. Okay? So you can always find the table of values. You can always just stick in the x's and find the f of x's. Okay. Now, the graph family. The entire family has this general equation right here. What is this saying? It's saying A, some constant, times the growth or decay factor, B, raised to the x minus h power plus k. What are we talking about here? Well, this k is called a shifter. It's going to cause the graph to shift up and down. If it's a positive value, it's going to shift up. If it's a negative value, it'll shift down. This h in here, even though it's a minus h, we'll shift it right and left. If it's minus h, it shifts this way. If it's a plus h, it shifts that way. Okay? The A in the front there causes it to be wider or skinnier and to be positive or negative. Okay? So let me just show you a couple of examples. Here I've got f of x is equal to 3 to the x power. Okay? Still goes through 1, and it's growing at a factor of 3, right? There is nothing being added onto it, so it's not being shifted up or down. There's nothing being added or subtracted to the x, so it's not being shifted right or left. And there's no value in front of it, constant in front of it, to make it any wider or skinnier. Okay? So, to change it and to move it up a little bit, I'm going to come in here and I'm going to add 4 onto the end of it. If I add 4 onto the end of it, this going from here, it goes up 4 units. And you can see that going from 1 up 4 units, it would go through 0.5. It would go through 5 right up here. Okay? And that's all it did, is moved up a little bit. Okay? See this one here? See that 0.1? It's now over here at 2. That means I had to have subtracted 2 from the x value, and that's what this x is telling you right there. That's what that blue is telling you right there. Now, if I come along and I multiply the whole thing by 2, instead of going through 1, I'm going through 2. See how it multiplied it and moved it up to 2? But if I multiplied it times 1/2, instead of going through 1, I would go through 1/2. If I multiplied it times a -3, I would go, instead of going through 1, I would go through -1. I'm sorry, it says 3, but it's -1 that it's being multiplied by. Can you see how those shifters are causing it to go up or down, and also to cause it to be wider or skinnier? Okay? Wider in the sense that this one is growing out slower and this one's growing out faster. Right? Okay? So those are the ways we use these parent functions here. Okay? You might want to save this screen. Just go up there to File, Save, and look at the whiteboard screens and save it as a PDF. Okay? You want to save all the screens, that's fine too. But save this screen so that you can use it. These parent functions are very helpful when you're solving some of these problems. For example, here's the problem. This is the family. A times b to the x, A times b to the x minus h plus k. Okay? So what do we do when we're graphing 3 times 2 to the x minus 1 plus 3? Well, the first thing I'm going to do is I'm going to stick in some values for x and get some values for y that come out over here. So at x equal to negative 2, we've got 3 and 3/8. So 1, 2, 3 and 3/8. It'd be somewhere in here. At negative 1, we're at 3 and 3/4. That's here somewhere. At 0, we're at 4 1/2. Well, there's 4 and there's a half. Right? And at 1, we're at 6. So that was 4 1/2, that's 5, and that's 6. And at 2, we're at 9. So 7, 8, 9. You can see how I got those points. You can see what I'm getting here. And that's what it looks like. Now, what is the value for the asymptote? The asymptote's this value right there. Y equals 3 in this situation. That would be my asymptote. That's easy to find. Why? Because it's the last value, that constant that's being added on. Y equals 3. That'd be my asymptote. My domain is going to be all real numbers. My range, sorry, I mean that for pop up. My range in this situation, it's going to go y greater than 3. All real numbers, y greater than 3. That's what you would get. Okay, where did I come up with these values? It's all stemming around that right there. Okay, it's going to cover all the x values, so my domain is going to be all real numbers. My range is going to go down to the asymptote but never equal it, so it's got to be y greater than 3. That's how you can find the domain, the range, and the asymptote. Cool? Okay, let's look at this one. What if they asked you to gave you a graph and said find the parent function, or no, find the equation of the function given that this is the parent function? Well, you know what? What they're doing is they're giving you the b value here. So let's look at the general equation. We've got f of x is equal to a times 1/2 to the x minus h plus k. Now I'm going to look at the graph a little bit here. See how that red line is going across there? That's telling you what the asymptote is. Y is equal to negative 5. Guess what? I can replace the k with a negative 5. I know that one right off the bat without having to worry about it any at all. Okay? I also can tell by looking at this graph. Let's see here. Can I tell anything else? Well, they gave me a couple of points here, didn't they? See how 0 is at negative 8? Right? So that means I can actually use that as one of my values. I got negative 8 times a, I'm sorry, negative 8 equals a times 1/2 raised to the x minus h minus 5. I can actually add the 5 to both sides and I get negative 3 is equal to a times 1/2 of x minus h. I can tell a has got to be a negative number. First of all, I can tell that because it's pointing down like this, right? And the one thing that I can tell about this a is that it has to be a negative number. Why? Because I can't raise 1/2 to any power and get a negative number, so a is going to have to be a negative number. So if I divide both sides by that a, what am I going to have? I'm going to have negative 3 over a is equal to 1/2 raised to the x minus h. What we're really trying to find here is this h. Now look at this. If I've got negative 3 over a, and that's got to be 1/2 raised to some power, you know what? That a has got to be some multiple of 2 greater than 3. So it's going to have to be negative 3 over 6 is equal to 1/2 raised to the x minus h. Well, this is actually negative number there, right? So a has got to be a negative number. I'm saying negative 6. So when I do that, that's going to be 1/2 is equal to 1/2 of x minus 8. Well, this has to be 1. So x minus h has got to be equal to 1, right? So can I find h from that? Well, you know what? We were at the point 0, 8. I forgot to stick that 0 in there. 0 minus h equals 1. So h has to equal negative 1. That tells me everything I need for this equation up here now. F of x equals negative 6. Where'd the negative 6 come from? Right there. Had to know that one, right? Times 1/2 of x and h is a negative 1. So I'm going to say minus a negative 1 or plus 1 minus 5. This would give you a graph of that same graph there without any problems whatsoever. And I forgot to start up my calculator, so I'm starting it up right now. Once it starts up, we will actually graph this, and I'll show you that it does work out to be the same graph, okay? Blink, 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 blink. Okay, there's my calculator. Not what I wanted to do. Thank you. There's my calculator. So I'm going to press y equals right here, and I'm going to clear this equation out of there. Now, we've got a negative 6. That's negative 6. Back up. Clear. Move up just a little bit so I can push the buttons. Thank you. Negative 6 times parenthesis 1 divided by 2, 1/2. Raised to a power of x plus 1. And I move over minus 5. Okay. When you're using the calculator, if you don't move over to the right here, it gets added up here in the exponent, and it really messes things up a little bit. So having keyed that in, I'm going to press enter, and I'm going to press graph just to make it graph for us. And okay, well, that looks pretty much correct. Let's look at some of the values to make certain we're getting the right values. If we look at 0, we get negative 8. At 1, we get 6.5. And those are the two values that we were given on the graph there. So I think we have got the graph correct. And that's what it looks like. Okay? So you see how we're using those tools, the asymptote, and then we're using the any one of the points to be able to find values that we can plug in here and get it to work. I use the one that goes through the y-axis equal to 8, 0, negative 8. That if I use that one, I know it's supposed to be equal to 1, so I know how far it was shifted down. And I know how far it was shifted down, so I know what the A must be in the front. Cool? You guys see how I did that? Okay. I appreciate the fact that you're sending me the fact that you're in Algebra 2 when you send questions. That really does help me find you and answer your questions a whole lot quicker. I look forward to seeing you either in tutoring or in the next class. Don't forget tutoring's on Tuesday, Wednesday, and Thursday. I'm there to answer your questions and help you as much as I can. I'll talk to you later.